Guys and girls, stop talking. Thank you. And what we're looking at is going from point slope form to slope intercept. So point slope is when you're given a point that's not the y-intercept, because if we are given the y-intercept, that's slope intercept. That's y equals mx plus b. Okay, so if we're given the slope and some point that the line goes through or passes through that's not the y-intercept, okay, we can input that ordered pair, that x and y, whatever it is, into slope point slope form. Okay, m is always our slope. Okay, so your x1 and your y1 get plugged in. Remember, the minus is in the equation. Okay, so if you have a negative for your x1 or y1, you still have to input that negative, okay, after the minus sign. Okay, so when you are given a point and a slope, you're going to write it out in this format. Okay, you'll make the substitutions of those three values. You're plugging in three numbers here. And then typically we want to solve for y and put it into slope intercept form, y equals mx plus b form. Okay, so here in this first example, I've got the slope. I'm going to go ahead and highlight while I've got my highlighter colors. So I'm going to highlight all my slopes here in all of these examples. Okay, and then the point that I'm given, that's going to be my x1, y1. Okay, so when I go to plug those in, oops, that's supposed to be a pen. Oops, I don't know why I wrote X there at the beginning. That's a Y. My bad. All right, so the formula is the same every time. If you want to go ahead and write this with the, you don't have to write actual blank lines here. You can just leave an empty space to fill in if you want. But there are three spaces that we are going to plug into for all of these. It's all ready to plug the values in. So we know that the slope gets plugged in to the spot where m goes. Just gonna, oops. I don't know why I wrote m on that last one. That was not what I should have done. Put a blank there. All right, so my slope here in the first one is 3. Okay, and then my x1 is 4, my y1 is 5. So once you have your three values plugged in where they go, then you're going to simplify and solve for y. So on the right, I can simplify by distributing. So you're going to distribute your slope first. If you want to put these steps up here, the solve for y part is going to always start with distribute your m. Okay, so we're going to distribute the m. Will here give us 3x minus 12. Then you're going to move your constant that's next to the y, whatever that y1 was, you're going to move it by addition or subtraction, depending on what sign it ends up. So here, this is minus 5, so the opposite operation is plus 5. Remember, we just got through doing proofs. What is that I'm doing? How would I justify that I'm adding 5 to both sides? Remember what property says I can do that? The addition property of equality. Remember, the properties of equality or what you do to one side, you do to the other. You're keeping the equation equal. You're keeping it balanced on the left and the right. So this is the addition property of equality, okay? Or if I subtract it, it'd be the subtraction property of equality. So I end up with y equals 3x minus 7. So that is slope-intercept form of my line. Okay, so and if you don't end up with your slope here matching the slope that they gave you, you've made a mistake somewhere, because the slope should stay the same. Okay, and then you should be able to see your y-intercept. If you wanted to check any of these, you could simply go and graph this in Desmos and check that it goes through that point 4, 5, and that it has the accurate slope, right? So you're welcome to check these in Desmos. Check them graphically if you're not confident. Okay, so after distributing the m, then you move your y1 by addition or subtraction. Okay, so when we say solve for y, those are the steps that we're doing. Okay, so here in this next one, I've got my slope is negative 1/3. My y1 is 3 and my x1 is 0. Oh, this one is actually much easier. I don't even have to do this. What kind of point is this if x is 0? No, what kind of point has an x as a 0? So that means from the origin, I've gone over 0 and up 3, right? So this is on the y-axis, isn't it? So this is my y-intercept. So I don't even have to start with this. I could go straight to mx plus b, couldn't I? So the slope is negative 1/3 and the y-intercept is 3. I don't even have to mess with this if I realize that that's my y-intercept. Now, if I don't make that connection that x is 0, so this is my y-intercept, can I get to this doing it this way? Yes. I could go ahead and distribute. I'd get negative 1/3 x and then nothing because that's 0. And then I would have to add that 3 over, which is where the plus 3 came from. Y'all feel okay about that one? Okay. All right. So now this one, this is not a y-intercept. So we are going to plug in here. So the y is 1, the x is negative 1, the slope is negative 2. So here there's an extra little something because you have a minus negative. What happens there? That's a plus. If you just want to make it a plus, like maybe you're writing like this and you just extend it and make it a big plus sign, that's fine. Okay, or if you want to show what I did, like, hey, that's minus negative, make it a plus, that's fine. If you want to completely rewrite it with a plus sign in another line, that's fine. All of that's kind of personal preference on showing your work. But once you have to make sure your sign is simplified in there before we do our distributing. So now we're going to distribute the negative 2. So that's negative 2x. And then that's negative 2 times positive 1. So that's negative 2. And then I move the 1 by addition. So I end up with y equals negative 2x minus 1. Just going to add a note here. Since we knew that that was the y-intercept, I used y equals mx plus b, because that's the y-intercept. So far, so good? All right. Moving on. Down here, we've got slope is negative 1. My y is negative 2. My x is 4. So again, I've got minus and negative. So this is going to be a plus. And then I need to distribute my negative 1. So I can write negative 1x. That's not incorrect, but it's unnecessary. You could just write negative x. You don't have to have the 1 coefficient. Okay, if you want it there, that's fine, but it's not necessary. And then what's a negative times a negative? So that's going to be plus 4. Then how am I going to move that constant away from the y? Yeah, this time it's subtraction. All those others above us, we were adding the number over. Okay, this time we're subtracting because we had minus a negative, it changed it to positive, so the opposite is subtract. Okay, so we subtract the 2 across, so that's the subtraction property of equality. So this is just negative x plus 2. All right. Next up, our slope is 0. Now, here's another one that's got a special case where I don't really have to use this point slope form if I notice the special case right away. Up here, the special case was, oh, I have y-intercept. Let me just use slope-intercept form. Okay, what's the special case in these last two are the slopes. Okay, we have a 0 slope and we have an undefined slope. So what type of line has a 0 slope? Straight, horizontal, or vertical? Okay, this is what is commonly mixed up. I'm hearing both answers, and I'm not surprised. That's why I reiterated this in those notes. Your slope is 0 if it's, because remember, rise over run. Can 0 be in the denominator? Can you divide by 0? No. So when you have your rise over run, it's okay for the rise to be 0, okay, which a horizontal line has a rise of 0 and a run of any number you want. But a vertical line would have a rise of whatever number and a run of 0. And you can't have a run of 0. So that's when it's undefined. So we've got a horizontal line here and a vertical line here. So I can plug into this and work it out just fine. If that's how you want to show it, go ahead. But if you make the connection, oh, if the slope is 0, what axis is this horizontal line going to cross? Going to cross the y-axis. It's just going to be y equals whatever number it crosses the y. What's the y value here? And that's it. Okay. If you have a vertical line, it's going to cross the x-axis. And where do they say it goes through the x-axis? At -3. So if you make the connection and you can do this shortcut, then great. You've got your equations. It's just y equals a number if it's horizontal, x equals a number if it's vertical. If you don't make that connection, it's okay, because if I came down here and I plugged in all of these values, it would still come out the same, and I'd realize, oh, 0 times anything, that's just 0. There's nothing left on the right. And then I would add the 6 over, and I would get y equals 6. So you can still get to it using point slope form, right? Now over here for undefined, if you tried to plug in, there's nothing to plug in, right? Undefined. I have no slope. Okay, so that should clue you in that this is not, I'm not going to be able to work it this way. Okay, so this is why it's undefined. I'm not going to be able to plug in a slope because there is no slope. Okay, so I would have to know that, oh, that's a vertical line, x equals, and then they tell us x is -3. We feel okay about these? Okay, are there any I know I wasn't here yesterday. Are there any questions over yesterday's lesson or practice that I need to go over? No? No. Okay, all right, I'm going to go activate today's practice. So if you have not finished 3.1 or 3.2, excuse me, you need to finish those first. Those are due first. The 3.1 was actually due last night, but it's still open for late credit through tomorrow. The 3.2 is due by tonight at 11:59 p.m. Okay, if you finish both of those, then you'll be able to start today.